So it always happens that once somebody starts asking one question, then everyone wants to ask a question. So keep that spirit going. It really gives a lot of support to a lot of speakers, because the essence of any talk is that if there are questions coming in, it means everyone was awake. All right, our next speaker is Puneet, and he's been on our stage before. We've seen him deliver some really good stellar talks. Recently, he moved from Coupa to GoDaddy and almost became, we got one more new sponsor. I'm still working on him to get a sponsor from GoDaddy too. Welcome, Puneet. He's going to talk to us in a deeper dive into Ruby with Lexers and Parsers. Puneet, over to you.
Thank you. Thank you. This, as Gautam said, is my 4th year attending, 3rd year consecutive speaking. This is a very special stage, but I am still nervous every single time I come. Um, the topic for today is from characters to meaning. We'll talk about how Lexer and Parser work in Ruby. You know, all of us are trying to find some meaning in life, but today we'll talk about Ruby, how it understands what we write. Welcome, Khamma Gani, traditional Jaipur style, me and my wife. I used my wife in examples last year. Yeah, audio is always a problem for me. Perfect, thank you. So me and my wife, welcome you all. I will use her in my examples, as I did last year. A bit about me, GoDaddy. Yeah, this, hopefully you're able to hear me fine. I am Puneet. Been in the industry for about 12 years now. A lot of people know me, so I'll skip my intro. I moved from Coupa to GoDaddy about 6 months ago. GoDaddy is a company which works in a very different domain and gave me an opportunity, so I took that leap of faith. While I was last year here on this stage and this year, I also, took this trek in August. It was a very good experience. I spent my birthday out in the Himalayas. A very good experience. A bit about GoDaddy. GoDaddy is a name which needs no introduction. A lot of you know GoDaddy as an OG name in the domain selling world. We are much more than that. Over the last 5 to 10 years, we have now become a trusted growth partner for millions of entrepreneurs. 21 million plus entrepreneurs use us globally to run their businesses online. Wide variety of portfolio and services we have. We can buy domains, we can build websites, we can deploy them securely using our tools, and so on and so forth. The list is very, very big. Today's agenda. Honestly, Lexer and Parser is a very difficult topic. I heard about this for the first time while I was in my college, 3rd year. There was a course called Compiler Design, and no compiler can be made without Lexer and Parser. I did not understand anything. Then I worked as a programmer in Ruby language for about 8-9 years. I never took the opportunity to understand how this works. But while I was here last year, a talk which was about ConfuScript, it inspired me to read about this in a bit more detail. And here I am talking about this. A disclaimer though, this talk will be a bird's eye view into how things operate. I'll not go into a lot of details. We'll start with grammar, the lexical grammar, the syntactical grammar. Then we'll talk about Lexer and Parser, how they work. Over the journey, we will use examples to understand what they do with the code that we write. Then we'll talk about ASTs, how ASTs do helping in parsing. And then we'll talk about how tools like Robocop, Brakeman use all of these to do what they do. Before that, some stories. How many people are married here? No? Yeah, quite a lot. More than what I expected. Some people like me, some men like me are not able to express even when we use words. On the other side, some women like my wife, they are able to express even without saying a single word. Aankhon aankhon mein, as they say, right? Similarly, or not similarly, on the contrary, When we write code, even with the LLMs, as of today, we have to still write or speak a prompt. There is nothing like telepathy, at least today. They may build it very soon, I don't know. As of today, we have to write or speak to get our code run. This example, my wife in a very good mood is asking me to make some tea for her because she wants to spend time with me and she values that time. When she tells me all of this, I take that, I process that, I ask myself, do I know how to make tea? The answer is no. Then I ask, can I use a YouTube video to understand how to make tea? The answer is maybe yes. Then I see, do I want to do it now? The answer is no. But then I go back and see the intent of what made my wife tell me this, and then I say, I should be doing this. Similarly, when we write a piece of program, give it to Ruby, it has to do a lot of these things behind to understand what is right, what is wrong, what it should do, what it should not do. Error out if the ask is not legitimate. We have been married for 9 years and I still repeat the same mistake most of the times and I keep wet towel on the bed. I don't know how many people do that, but I still do that. She is a very calm person, but at times, after 9 years, she'll like lose her thing and then instead of telling me to remove the towel from the bed, she'll probably taunt me and say, hey, how many times have I told you to not do the same thing? For a bit and this should be easy. It should be easy, but I make the same mistake a lot of times with her. The point I'm trying to make here is, here, instead of asking me to do something in a straight way, she's keeping things around. She's going around and around and around. Similarly, when we write code in Ruby, as Gautam said, a lot of ways of doing things. Some are easy, some are hard. We, instead of doing a if else, we will do unless else. When there is no need of metaprogramming, we will use metaprogramming. All of these nuances, they make it difficult for the programming language to interpret, but they still do that. How all of this happens? Be it my wife talking to me, be it a 6-month-old child talking to her mother, or be it a programmer writing some piece of code. All of this behind the scene needs some piece of grammar to understand. Grammar is something which tells what is right, what is wrong, what we should do, what we should not do. Grammar can be broken down in two pieces. Um, Lexical grammar, it is all about building words from characters. Building words from characters. It defines what words are valid and what words are not valid. English, love is a valid word, lovey is not. Ruby, def and end are valid keywords, but defy is not a keyword. Syntactical grammar, this comes into picture when we are trying to build sentences from words. Trying to build sentences from words. A list of valid words, if you put them together, will not always make a sentence. 3 words in English, apple, banana, pear, they are all fruits, yes, but if you put them together, English language will say it's an invalid sentence because it has rules. Every sentence should have this and that, and here they are not, so it's an invalid sentence. Similarly, in Ruby, def something end is valid, but if you flip it, end something def is not valid. The grammar defines all of that. With this thing, we have learned a story, we have got some theory into how this works. Now let's jump into Ruby, how the Ruby programming language understands all of this. 2 pieces this talk will be in. The first piece is Lexer. Lexer module is responsible for generating a stream of tokens from the code that we write. A stream of tokens from the code that we write. While it does that, it also adds some metadata. The metadata is very important because it is able to keep the context of what original line of code led to those stream of tokens. This is very important and we'll talk about this how in the subsequent slides. While it does all the lexing things, the most important thing is context sensitivity. There are some characters in Ruby which are ambiguous, like minus. -1 means something else, 5 minus 1 suddenly means something else. These characters are ambiguous. And the Lexer module is responsible for resolving these ambiguities. Some example. Uh, Maybe oh yeah, but I'll turn this side and I'll use this as an example. So, if anybody is curious to see what the output of Lexer is, they can use something called Ripper. Ripper.lex is a method which gives output of tokens. A simple string, put hello world. As you see, this is the metadata on the left, which has the line number and the character number. It goes a long way. On the right, if you see, these are states, CM, dark, and end, all of that. They help Ruby understand the state. These things that you see in the middle, on indent, on space, these are the meanings that it is trying to derive from the word. If you see this thing, double quote, the double quote revolved my string. The first character of double quote says on string beginning. The second character of double quote says on string end. Context is what comes into picture here. One more example of context sensitivity, division operator. Like 1 divided by 2 means something else. It's a division operator. And slash bar something, slash, it's a regex. If you see, yeah, this one, on op, it says division operator, operation, division is an operator. On the second line, if you see, it is parsing it as regex because it has 2 backslashes. It understands it is regex. Errors. A lot of you may have seen some errors while you write Ruby code. Some of them may come from the Lexer module. Let's say when you open up a double quote string but you don't close it, it's an error. When you open a regex, don't close it, it's an error. And a lot of other error scenarios you can find being thrown by the Lexer module. Parser module takes the output of the Lexer module, applies grammar on top of that, and tries to figure out if what we have given makes a valid Ruby program or not. A pretty complicated stuff, but to oversimplify, it will try to make meaning of the tokens. And more importantly, it will tell can it execute that code or not. While it does this, one of the important things it will take care of is it will take care of operator precedence and all the good things. Example, to see how the output of parser looks like, we can use something like Ripper again, SXP. The example is simple, -1 star star 2. All of us would know that star star has more precedence than minus, so the Ruby parser also knows that, and the result of that is, if you see, the binary operator is applied first. The binary operator of star star is applied first on 1 and 2, and the result of that is applied as a unary to the minus operator. The precedence is taken care of by the parser module. Oh. Yeah. Some examples of how this would parse different code snippets. The first one we saw, -1 star star 2, because -1 star star has more precedence. That's where it processes it. If you want to change it, you always can write a parameter here that makes Ruby change the context. Chained operators, 1 plus 2 into 3. Star has more precedence than 1, than plus. So 2 star 3 is applied first. If you want to change it, you always can using these brackets. Similarly, more examples. This slide talks about more examples. The one I'll talk about here is this. So all of us may know that Ruby 3 dot something made some changes by which it now supports some new syntaxes. The hash, the key value, if the value is the same variable, then the key, it now said it's optional. There is no way, there is no mandatory need for you to put it. How does Ruby parse that? Maybe somebody went and added some more grammar and said that these are now also valid. Um, Similarly, if you see a def without an end is now also a valid syntax unless it is in the same line. That also works because of some changes here done in Ruby 3 dot something. ASTs, abstract syntax tree. Very complicated topic, but to oversimplify, ASTs are used to give a tree-like representation of the output of the parser module. This tree-like representation makes it easier for systems to analyze on top of that. The traversal is more optimal because it's tree-like structure. We can generate these kind of ASTs using a lot of tools. One example is the parser module. If you see a simple function def add ab a plus b end, the AST will look like a tree, but I was not able to represent it as a tree, and hence I've been putting it like this. But if you see the first line def add, the second line talks about the method definition. It says arguments, two arguments A and B. Because there are no types in Ruby, here we don't have types. The second line says send A local variable, B local variable, and then the plus in between. So it is a representation of A plus B. They're all both local variables. And send is the signal to evaluate. Some more examples, object.foo. Here if you see, object is a local variable. Hence you see lvar object. On this lvar object, we are doing a send on a method called foo. So we are calling foo on a local variable. This is what this line sort of conveys. 1 plus 2 plus 3, 1 plus 2 into 3, this example, as we know, star has more precedence. So if you see here, send 2 star 3 is evaluated first. The result of this goes to the plus. So this thing, AST, represents. This example we saw already, so I think I can skip it. How can we use ASTs in real life? All of us, most of us would have used tools like Brickman, Robocop. Robocop is like code linter. Out and flag that this user ID is not a str, it is dstr, it is dynamic string. It also sees that to a where clause we are passing a dynamic string as a parameter, and this is a violation. So it reports back. If you remember, the output of the Lexer module also had the line numbers in that. Using the meta information which is already there somewhere, these tools are able to report back and say, hey, on this line of your code, this is something wrong, this is what it is, and go and fix it. And they are also able to suggest, like do this, because they know the pattern and they have a solution also. Using all of this, they tie it together and show a suggested fix also. Different example or easier example of code styling. Self count is equal to self count plus 1. This self here is redundant. It generates the AST, sees hey. On send you are passing self again, which is redundant, so it flags out and says hey, not required. As a fix, just remove the self. Key takeaways. Somebody just asked me yesterday that what brought me here for the third time in a row. As an engineering manager, I don't even code a lot. The team that I work with does not use Ruby at all. But I'm still here because of two reasons. And I think I have 2 minutes, so I'll take 2 more minutes to talk about that. With the LLMs, the change that all of us are seeing is people are relying on these tools. Like using these tools is something else, which is what I encourage, yes. But people are relying on these tools to write their code, which is not a good thing, especially for young engineers. If they rely, they will never learn how the things work internally. it's fine if you leave all the Lexer parser thing here, but if I can suggest, make it a habit of understanding what lies beneath, understand how things work internally. Without that, we will keep making these LLMs smarter, but we may be going in a different direction, which is not good for us. So keep continuing the habit of understanding how things work. Second thing is, pandemic changed a culture. We started remote work. LLMs are changing that culture even again, and vibe coding is now a thing, which is very, very cool. I do vibe coding a lot when I code, but the point I'm trying to make here is we are losing connections. As you see in this picture, a senior developer is working with a young developer, teaching him, coaching him, mentoring him. When you do all of this, you make human connections, and human connections make us humans. Uh, Vibe coding should not replace, reduce maybe yes, but should not replace all of this completely, because if it does, then we may no longer be good humans, is what I feel. That's it. Thank you for patiently listening.